Hello, everyone. Welcome back to Deliverable 4 for our application SignIt. It's a sign language translation system that's built on Android Studio and YOLO v5 machine learning models. On the agenda for today, we have a couple of items to cover. I'm going to reintroduce the team and roles, the improvements made from professor's feedback, project description, teamwork agreement, personas, our minimal viable product as well. She will be handling the technology, algorithms, and all diagrams. Um, Fariel will cover the sprint summaries for sprint 2 and 3, the product backlog for the entire project, as well as sprint 4's backlog. And I will then cover the metrics, summary of the retrospective, and Renee will cover the code samples and project demo. For our team, my name is Joseph Annunziata, and I'm the Scrum Master and Machine Learning Engineer. Fariel Alam is the UI developer and testing engineer. Renee Irias is full stack developer and UI developer. And Shijo is backend developer and machine learning engineer. These are the improvements made from Professor Wong's feedback. We changed a bunch of situations with the user stories in the product backlog, and we included story point estimates. In the past, we did not include story point estimates. We just included a key as reference. We also removed the acceptance criteria slides and merged them with the user stories in a different format that's easier to read and understand. We made changes to the completed and committed stories and the team velocity burn down charts and ratios, all regarding story point estimates instead of the actual story count. And we also included code at the end of the presentation as well for different aspects of our project. Our problem statement, deaf and hearing impaired people are impacted greatly with issues of loneliness and marginalization based off of their lack of communication and other people's lack of understanding of sign language. So we sought out for our project to develop an application system that can translate sign language in a live format. Our teamwork agreement was essentially made the same. We kept in the retrospective meetings that they are mandatory and that everybody must agree to meet on those retrospective meetings. And I also included submission of slides and videos for the presentation so that everything is not sent into the folder for submission late or out on the day of the deadline, just so everybody has a chance to review everything. Persona 1 is Jane, an attentive mother who's trying to communicate with her hearing impaired child. Persona 2 is Simon, a project manager who's looking to include Paul, who is deaf, in group meetings at the workplace. And Jack is an educator who is looking to utilize a technology to teach and to help children understand sign language in the classroom setting. Our minimal viable product is an Android application that includes a login page with a field to enter email, password, and an alternative Google sign-in button, and a button to register new profiles. The registration page also has a field to enter email, password, a button to complete the registration, and a button to redirect back to the login page. The home page is a grid style dashboard with 4 buttons. There's one button to access the camera. There's a button for the how-to guide, a button to access settings, and a button to log out of the app. The camera is also a live feed from the mobile device camera, and that's accessed directly from the camera access button. And our application also includes a machine learning model. It's a custom built model built within a Python notebook. And we used an alternative model called YOLO v5 compared to the original TensorFlow model that we had used previously. This model was trained on a custom-made data set of 5 different expressions. Hello, good, yes, no, thank you, and I love you. This model is able to distinguish two hands, their positions and poses accurately within the camera view. And the integration of the machine learning model and the Android application was made based off of Arohi Singla's GitHub repository, as well as her YouTube video tutorials.
Okay, so now let's talk about technologies. As for the technology, we didn't make too much change since our last deliverable. We use Python for the model training, and we use YOLO v5. Underneath the hood, YOLO v5 use TensorFlow for the model training. Thanks for YOLO v5, the model training process is a lot easier. And we use OpenCV to invoke the camera to let computers see our movement or our gestures. And as for our application wise, we use Android Studio and Java and Kotlin for the Android application development. And as for the model labeling, we use label image, which is a framework, make it a lot easier for us to label images with our gestures. And as for the machine learning process, again, we didn't make too much change on the model itself. And at the very beginning, we collect data from for the training and for the testing, and we pre-process the data and create labels for those gestures. And then we convert the data to fit YOLO requirements. Again, YOLO requires certain format of input. So in this step, we transfer our data to a YOLO to a YOLO recognizable data set. Then we split 80% for the training and 20% of data for testing. And eventually, we utilize YOLO v5 for the model training, and then we save the weight. Then we evaluating user confusion matrix. Then at the very last step, we test in the real time. So here's the conceptual architecture diagram. The user opens application and invoke the camera function, which is the core functionality of our application. Then the camera will collecting the user's data, which means the image of the gestures, and we just feed the images to the model, which is trained by YOLO v5, and underneath the hood, YOLO v5 uses TensorFlow. Then the model will just give us feedback, like what kind of gesture it is. Then the user will get this feedback. And here's just sequence diagram. The user opens the application, which is Android application. Then the user will see a starter a login screen. Then the user press button to invoke a camera, which has a call functionality. Then the image or the video will be rendered in real time, so the user will see it. Then the image captured by the camera will send to the machine learning model. Then the model will take these take these feed. Then will return the feedback after the calculation, then will display the prediction results with possibilities, and user will get real-time feedback. So here is the class diagram. Everything is surrounded with this Android Studio application, which is our main application. So the user will interact with this application directly. As for the user, we have a user ID, which is um, unique user ID, and we'll have email and password attributes in this user. And the user will use the device camera, and the camera captured image then will just feed to the machine learning model. The model will have a label, which is string, and accuracy score, which is a float. And as for the camera, we use bitmap to decompose the like input image to a machine learning model recognizable, especially TF-Lite model recognizable data input, in order to put this data as a feed into our machine learning model algorithm. Then as for the DVM, we also have like key is the user ID, which is the primary key, and the email and the password. In our database, also we have these attributes. Here's the use case diagram. The user opened the application. The user will see the login screen. Then after logging, it will navigate to the camera in order to use the application, which is the main functionality of our application. Then the camera will capture the gestures, and the feedback will give, I'm sorry, the fee. Then those images will be feed to the machine learning model that will translate those gestures. In our case, we have 5 phrases, gestures we can recognize. The ones are hello, yes, no, I love you, and thanks. So after the translation or prediction by the model, the the application will just display the results. And after done using this application, user can, of course, log out. And the login and log out function is in our authentication service, of course.
Hello, my name is Faryal Alam. I am the UI developer as well as the testing engineer of our team High Five, and I'll be going over our last sprint with you. So let's get started. I'll talk about a little bit about the user stories, about our test cases, and the user stories that were completed, that are still in progress, and some of them that were not completed. So let's take a look at this slide over here. We have the sprint 3 recap. As per our feedback for our last sprint, we were told to kind of merge our acceptance criteria and our user stories into one table. So as you can see over here, we have the user stories in the gray line that extends from the key and the estimation over here, and then it says the status about it, if it's completed or if and the location of it. And then in the middle 3 columns, we have the scenario, the summary, and the criteria. That is the acceptance criteria basically, and this is how we merge them together. So for the sprint 3 recap, we had the user story key 6, where we had that as a project manager, I want to be able to log out of the app. So this is the log out functionality or scenario, and this was completed successfully, as well as the customization of the machine learning data set. And for this one, the criteria was that the app must be able to be customizable in Python notebooks and easily updated in Android Studio, and we completed that as well. The location for this is the machine learning model. Now over here, you see the product backlog of our user stories. We have, again, the keys, the estimation. So the estimation is basically telling us on a scale from 1 to 5 about how high or low the duration and the intensity of each user story was, from 1 being the lowest and 5 being the highest. So over here, for example, user story 1, we marked it as 2. In this case, we needed to have a secure traditional login where the system must securely handle the login process with encryption and provide access only upon successful authentication. And this was completed successfully, and it can be found on our login page. Similarly, we set out for a secure Google login, and our user story relates to this as well. As a parent, I want to log into the app via my Google account, and again, that's completed. One thing that is still in progress was the user story. As a project manager, I want to be able to recover or reset my password if I forget it. And this was the scenario about password recovery, and the criteria for that was that the app must provide a secure and user-friendly process for password recovery and reset. And this is something that's still in progress and can be found on the login page. Now we also have the user story key, as you can see, is getting higher or bigger. And the estimation is also changing depending on the user story. For instance, for the key 04. We have the estimation 2, and the user story for that was that as a parent, I want to access a homepage with the different app features. This is something that we completed, can be found on our homepage, which is the homepage. And this was marked as estimation 2. Something that with an estimation of 5 indicates that it took either a lot of time to complete, as well as the hardness or the intensity level of it was much more higher, and that was granting camera permission for live translation feature. Again, another user story that we completed successfully and can be found on the camera. The logout functionality is another of the functionalities or the user stories that we completed successfully. Moving on to accessing the app for sign language translation. As a project manager, I want the app to translate my sign language gestures, and this is again completed and can be found on the machine learning model or the camera. The live translation feature with interactive overlay was another scenario that we set out to complete and also got completed successfully, can be found on the camera. So what this is doing is that the app is providing an overlay on recognized gestures on the live camera feed. The user story that will relate to that is that as a parent, I want to see a visual overlay of my gestures that are being captured by the camera. So that would be this. Then moving on to something that's still in progress would be our model sensitivity settings. As an educator, I want to be able to adjust the sensitivity settings, and this is something that is still in progress. So the app must provide options to adjust sensitivity settings for the machine learning model, and this isn't something that we have completed yet. And so on. We have again the granting camera permission for live translation feature. It was one of the hardest things that we did, and this is completed successfully. Then we have the another acceptance criteria, or the related user story of it would be, as an educator, I want to view a history of my translations. This would relate back to the database for translation history, and this isn't something that we have started yet. It would have been on the history page, so the app should have a securely store translation log, and the user should have been able to access it on the home page, and this isn't something that we got to start yet. Then we have another user story, which would be our last user story, I believe, signed at 12. As an educator, I want to be able to customize machine learning model with my own data sets in a Python notebook, which again would relate to the acceptance criteria of customizing the machine learning data set, and that is completed successfully and can be found on the machine learning model. This is complete because the app is able to be customized. It is customizable in the Python notebooks and can easily be updated in Android Studio as well. Now over here you can see the sprint summary of sprint 2 with this chart, and the user stories that were completed successfully. We have the status here, we have the summaries here, the keys relating to it, and the dates associated with them. So the user story 1, 2, 4, and 10 were completed successfully. Over here we have the sprint summary of sprint 3. Again, the same layout. We have the chart over there and the table that indicates the user stories and their status of it being completed, as well as their related keys and dates. Now, these are our sprint 4 backlog, so the stories that we committed to. First of all, we have the signed key 03, and this was about the password recovery. So this is something that is still in progress. It would have related to the user story of a project manager wanting to recover or reset their password if in case they forgot it. And this would be something that they could find on the login page. Again, continuing on the stories that we've committed to was granting camera permission for live translation features, and this was completed successfully, can be found on the camera location. And the criteria for this was that the app must request and obtain user permissions to access the camera for the live translation feature to function properly, ensuring the user's privacy is respected and the feature operates seamlessly. We also have accessing the app for sign language translation and the live translation feature with the interactive overlay. Both of these acceptance criteria relating to their respective user stories were completed successfully. And you can see that on the status column as well as the location and where they can be found. Then we also have the model sensitivity settings as well as the database for translation history. So about the model sensitivity settings, this is something that we're still in progress. You can see that on the status column. And then for the database for translation history, this is another user story or case or criteria that was not started yet and could have been found on the history page. Now let's talk about the test cases. So the test cases are not much different from last sprint. The first couple of them are still the same. So we have test case 1, 2, which talks about the verification of the login, one with the traditional route of the username and password, one with the Google account. Then we have testing the machine learning model with the different key points of hello, yes, no, I love you, thanks, and so on. And one new test case that we added to the test cases was test case 0011, which was after or once we successfully implemented the machine learning model into our Android Studio, which was testing the camera with the integrated machine learning model. Again, there is no testing data needed for here, and the steps are pretty straightforward. We're navigating to the camera feature. We click on the camera button, and the camera button is visible and recognizing as well as translating the shown hand gesture, which all happened successfully, so we marked it as pass. Again, here's a summary of the completed stories for Sprint 4. We have the granting camera permission for live translation features. We have the accessing app for sign language translation. We have the live translation feature with the interactive overlay. And now the stories that were not completed for Sprint 4, again, are password recovery, something that is still in progress, and the model sensitivity settings, as well as the database for translation history. This would sum up my part. I hope, thank you for your time.
As far as the metrics are concerned, I made changes to the team velocity charts based off of story points. So for Sprint 4, the team velocity was 24 committed and 15 completed. Historical or the average team velocity, it shows that in Sprint 2, we had committed to 18 story points and we completed 11. Sprint 3, we completed 7 out of the committed 31. And Sprint 4, we completed 15 out of the 24 that we had committed to. The Sprint 4 burn down chart. This is based off of the 15 estimation points that we completed out of the 24 that we had committed to over the time period from April 8th to May 5th. This is the historical or average burn down chart for the entirety of the project for sprints 2, 3, and 4. And those dates range from February 12th to May 5th. This is the Sprint 4 completed to committed ratio. Committed is 24 story point estimations. Completed was 15 story point estimations, and that ratio is 62.50. The average completed committed ratio. So Sprint 2's ratio was 61.11. Sprint 3 was 22.58. Sprint 4 was 62.50. So the average is 48.73. And the historical is committed story point estimations for the entirety of the project was 42. Completed story point estimations was 33. So the historical ratio is 78.57%. As far as our retrospective, we listened to Professor Wong's feedback regarding conducting the retrospective, and we went with a silent review for what went well and what to improve upon, or what needed improvements. So to summarize the what went well, um, we integrated the model with our Android app in a collaborative manner where everybody was involved in the process. The team handled tasks a lot faster than expected regarding the story point estimations as well. And there was collaboration focused on specific tasks at hand, especially because we were nearing the end of the semester. So the team merged together to collaborate on those specific tasks to get everything done. So what can be improved? So we had discussed that time management regarding specific tasks, due and submission due dates as well. There were some issues this past deliverable and in the previous where one of the teammates was given tasks completed later than expected, or submission items that were due later than expected. Um, and they were submitted later than expected. So we had a discussion about how to improve upon that and setting hard deadlines, which I'll discuss in the action items. There's also time management regarding the team meetings, regarding meeting times, as well as keeping the meetings condensed, and just focused on specific tasks. We also discussed issues with communication about task progress. There wasn't a whole lot of communication about specific tasks that were being completed. So some of the teammates weren't sure what was completed, what wasn't, until the next weekly meeting was completed. So we had a discussion about how to work and improve upon that as well. And another thing that can be improved upon is the meeting times. And this was an issue that we had throughout the entire project length. Um, and it was just due to all the teammates' time constraints, time zone changes, work changes, which couldn't really be too flexible with working on it, but we made it work as best as we could. And the action items or how to improve. So the biggest one was to set hard deadlines for tasks and item submissions. Um, just so everybody was on the same page. It should have been probably set at the beginning of the semester of when exactly things were due, and when things were supposed to be submitted, so that we didn't have somebody waiting a whole weekend just to check on people's slides and review work, and waste a lot of that time. The other improvement was to do periodic updates on tasks, which we just discussed in the how to improve, in the improvements, what needs improvements. So the periodic updates would be through either Discord or quick Zoom calls in addition to the weekly meetings. Establishing a consistent schedule when the team is free, possibly outside of work days, regarding the weekly team meetings. We towards the end of the project, we had to meet at 9 p.m. on Mondays, just because of everybody's schedules. So maybe coming up with a schedule for potential meeting times on the weekends, Saturday or Sundays, if people were available. We chose work days just because we figured that everybody would be doing different activities with their families or friends on the weekends. Um, Also cross-checking work and allotting time to review other teammates' works. So there were some issues where um, items were completed but not reviewed, especially at being after being asked a couple times to review those items before submissions, and that wasn't being done. So just making sure that everybody was allotting time to review other teammates' work throughout the process. Additionally, and finally, to create separate video calls focusing on specific tasks, such as specific code integrations, in addition to the weekly team meetings. And that was certain tasks basically were completed, but some of the teammates weren't available for calls, or in addition to the weekly meetings, and the other teammates who were working on different parts of that task needed information from that other teammate. So just to focus also on adding, pop-up calls instead of just the weekly meetings to discuss those ideas and that information. Overall, we also discussed at the end of the retrospective that basically our project did really well. We got everything done in time, and actually pretty much almost all user stories completed before the semester was done. And um, we also discussed that for the action items throughout each retrospective, we really narrowed it down to, smaller items, and not such large items that we started out with in the beginning of the semester. So going forward, we talked about how if this project was extended for another semester, um, that we would even narrow it down even further. And we've made great improvements throughout the course of just the past couple of months. So going further, we would make even more improvements to that. We were a very flexible and workable team, which made it really good and really possible to implement what our app is supposed to do functionality wise, and actually what it is itself, with the model integration at the end.
Hello, my name is Rene Diaz. I'm a full stack developer and I will be introducing a little bit of our app structure. Our app aims to facilitate communication with the hearing impaired community through intuitive features and user-friendly design. Our interface comprises four card buttons. Each card button serves as a distinct function, enhancing user experience and accessibility. The camera live feed screen displays real-time translation of hand sign gestures into English. Users can interact with the app by performing sign language gestures, and the app provides translation for improved communication. We had added a how-to guide section that offers valuable tips and resources for effectively using the app. The registration screen allows users to create an account with Signet by providing their email and password. Users can easily register and gain access to Signet's features and services. The login screen offers two convenient methods for accessing Signet. Users can log in using their Google account, email, or by entering their email and password directly into the app. This dual login approach ensures flexibility and easy access for all of our users. In this slide, you can see the screenshots for the main menu and the sign in screen and the sign up page. The next two screenshots are the how-to guide, where you can see all the different tips on how to use the app. And the next one is the live feed camera, where you'll be able to see when when the app it's translating to English. Here you can see our Firebase database, where all the login information about the login will be stored. On this slide, you can see the creation of the XML for the login page, where we have used text view, edit text, and buttons. The XML for the homepage consists of a grid layout with 4 card views that work as a buttons, like the camera button, the how-to guide, settings, and the logout button. Here is a screenshot when trying to log in or sign up. The email or password cannot be empty. And here for our model integration, this is a screenshot. You can see how we do the bitmap reduction to scale the pixels to a better output. And, and for the final integration, you can see in this screenshot the parameters needed for our app to integrate with the model. Here on this portion, I'm showing you a little bit of the machine learning code that we used for our model. So then we are doing the model conversion to TensorFlow.
So this is the wiki page link for our group's project. It includes the source code as well as the wiki page descriptions of all the items, as well as links to all the deliverable items, papers, charts, retrospective summaries as well. And finally, this is the GitHub link that we used as a reference for our model integration in Android Studio. So that's the link to the tutorial for that, as well as the YouTube tutorial. And on to the live demo. And here is a live demo of our MVP. Sign it as an application for an Android device. This demo was completed by Renee on his Android device. First, he's going to show the sign up screen. And then go back to the login screen where he's going to sign in with Google. And now he's going to access the how-to guide, which is a built-in guide just to navigate the app. He's now going to log out to show that functionality. And he's going to log back in with Google and access the camera feature with the TensorFlow Lite model with the YOLO v5. You can see the bounding box and the label and predictions around the hand gesture signs. The model isn't 100% accurate in this detection right now. It was limited with the data set that we used, but a point of improvement that we had considered for the application was to add more photos of different hand signs with different lighting, different background, in different colors, just to differentiate and make sure that the machine learning model can pick up on these differences and make a more accurate prediction.